Hello students, this is a video about bending light. So I will explain very quick, some of the actions we have to do on the simulation to understand what is reflection, what is refraction, right? So first we're gonna kick in intro, and then here we have, the source of the rays, right? And I can just click on these and then now I have the incident rate. There is this ray over here, the reflected rate, that is this one, and the refracted rate, that is this one. So what can I do? I have different materials. So in this case, the material on the top is air. I can change the material to water, for example. I want that you look at this number, that is the index of refraction. So when you are changing the material, the index of refraction is also changing, right? So this is very important to understand that you can change the material or uh, the mediums that are involved in the problem. So you can have air and water, and you can have air and glass, for example. And always just look at the index of refraction, how it's changing, when you change the material. So let us leave it like air and water. I will bring now this protractor here, and then I'm going to start just changing the angle of the incident rate, right? For example, here the angle, let us start because you measure the angle from the vertical, from the normal. So there is a line here that is vertical, that is perpendicular to the interface between the two mediums, right? And in this case, what happens is that you are going to measure the incident angle, the refracted angle, and the reflected angle respect this normal. So the normal is a vertical line perpendicular to the interface between the two materials. So if I move right onto to this position now, my ray source, right? What happens is that my angle of incident angle, the angle of the incident rate is now 10 degrees, right? Because you are measuring from the perpendicular from the vertical. So you have 10 degrees here. You can then find out, right, that the reflected rate is also in the order of 10 degree, and the refracted rate is, for this case, about 6 degree. Now you're going to move this to 20 degrees, and then when I move to 20 degrees, right, I have then also my reflected rate or my reflected angle about 20 degree, my refracted angle or the angle of the refracted ray just about like 14 degrees. Like that, you will be moving, uh, through different angles your rate, your incident rate, and you are going to be recording. That means you're going to be writing on it on the table that is given, what is the refracted rate and the reflected rate for each case, right? If you change the materials, for example, if I change glass, you're going to see how the reflected rate is not affected at all, right? So always the incident angle or the angle of the incident rate and the angle of the reflected rate are basically the same, but the angle of the refracted rate is going to change, right? So what happens is, you look at this, is that the angle of the refracted rate or the refracted angle move either toward the normal. This dashed line is the normal. So move toward the normal or move away from the normal, depending on how it's changing the index of refraction, right? So for example, when I have air, to water, right? You see how when the ray pass through the interface, right, is going to move toward the normal. And it's because the index of refraction of the material 2 is greater than the index of refraction of the material 1. If I increase more the index of refraction of the material 2, so I will change instead of water, I will use glass, so increasing the index of refraction, now the refracted ray move even more toward the normal. If I use water, move away from the normal. If you change, the material, so you say my material on the top, so my material 1 would be glass and my material 2 would be water. So as now the index of refraction of the material 1 is higher than the index of refraction of the material 2, you're going to see how the refracted angle is increasing. So it's like the refracted rate is moving away from the normal. So if I decrease even more, the material 2's index of refraction, so I just convert this into air. Well, this is now just pure reflection, so there is no refraction at all. I will just increasing this index, and there is a critical value here, of the index of refraction, where we have, a value of refraction, So you see in this case that when you are going from a medium with a higher index of refraction to a medium with lowest index of refraction, you see how the refracted rate moves away from the normal. So the idea here is just to measure, the incident angle, the reflected angle, and the refracted angle. And then later we're going to use the Snell's law, and the Snell's law basically establishes the relation between the index of refraction of the two materials and the angles, the incident angle and the refracted angle, right? So if we know the materials, for example, material 1, and we measure the incident angle and the refracted angle, and we graph these in a coordinate system, in a rectangular coordinate system, we're going to get on a straight line. That is basically what I asked you to do in the lab. And then, depending on what you use as x coordinate, because you're gonna be graphing the sine of the angle of incident versus the sine of the angle of refraction. So depending who is in the x-axis, either the angles of incident angle or the refracted or the angle of refraction, you're gonna have that the slope of the line is gonna be the index of refraction, or the reciprocal of the slope is going to be the index of refraction of the material that is unknown. So this is something that I explained very carefully in the question of the lab. So it's pretty clear there, in what axis you have to graph or where you have to put the sign of the incident angle, what axis is the sign of the incident angle, what axis is the sign of the refracted angle, and I explained clearly there, how then the slope becomes, the index of refraction. So just follow the instructions that I give you in the lab, and it's going to be pretty easy to do it. What you have to do is basically to be recording the values of incident angle, refracted angle, reflected angle, and to just mention some conclusions, some conclusions that are coming from your observation of the behavior of the rays, right? And then basically at the end is just to estimate, to calculate the index of refraction with the data that we have been collecting, in the previous steps. So this is what we have really for the lab number 7. It's not really hard. The protector, you don't have to be rotating the protector here. You can just measure from 0. And for example, here, if I would measure, the angle of the refracted angle, the angle of refraction, what I'm going to do is measuring from the bottom, so all this way over here. This is like approximately like 81 degree, what we have, for example, for this ray over here. And for this one, we have like what? Almost 50, 49 degrees approximately. then this is, in the same way we can measure this angle over here. That is like a what, like a uh, 50 degree approximately, 49, 50 degree approximately. Because remember that always the incident angle and the angle of reflection are the same, right? So well, basically this is what you have to do with the lab number 7. I hope the video will be useful, to complete the lab. Thank you.